From this point, we will prove statements in geometry using direct method. Direct method of proof utilizes the conditional statement if P, then Q. To do this, start by assuming that the hypothesis P is true and show that the conclusion Q must therefore be true. We will use the two-column form to report our proof. Unlike in indirect method, we write our proof in paragraph form. This table is the two-column form for reporting a direct proof. Series of statements are written in the first column, and each statement is supported by a valid reason. Giving the next statement is not allowed unless the preceding statement is justified. Let us have some examples. As a starter, we take statement in algebra. If 3 times x minus 2 is 12, then prove that x is equal to 6. In this statement, the hypothesis P is 3 times x minus 2 equals 12, while the conclusion Q is x equals to 6. Pause this video to recall the following axioms to support the statements in our two-column proof in this particular problem. Reflexive property, addition property of equality, multiplication property of equality, and distributive property. We are now ready to prove the statement above. Again, start with the hypothesis and assume it true because it is given as a true statement. Now, statement 2 can be made because statement 1 is justified. Statement 2 is 3x minus 6 is 12. This is true because the distributive property allows 3 be multiplied by x and by negative 2 in statement number 1. Next, statement 3 is true because reflexive property states any number is equal to itself. Equations in statement 2 and statement 3 can be added to have equation in statement 4. This is supported by addition property of equality. Statement 5 is also true by the same reason in statement 3. Finally, we have proven that x is equal to 6 in statement 6 because equations in statement 4 and statement 5 can be multiplied and is supported by multiplication property of equality. Indirect proof, start with the hypothesis, make series of statements until you reach the desired conclusion. What do these numerals in bracket mean? This time let us take a statement in geometry. In the figure, if the length of segment AX is equal to the length of segment BC and the length of segment XC is equal to the length of segment CD, then prove that the length of segment AC is equal to the length of segment BD. The following axioms and definitions support our statement in this particular proof. Addition property of equality, definition of between, and substitution principle. Remember, begin with the hypothesis. In this particular problem, we have two hypotheses, and these two are given as a true statements. Since all of the distances in statement 1 and 2 are real numbers, we can use addition property of equality to get statement 3. In the figure, we see that C is between B and D. The definition of between tells us that statement 4 is true. Likewise, X is between A and C. The definition of between tells us that statement 5 is also true. Since the expressions in statement 3 are equal to expressions in statements 4 and 5, we can use substitution principle to get statement 6, which is the conclusion.